All right, question 2 on the AP Stats practice test. In this problem, we're told that we have a random sample of 374 pennies, and we're recording the age of each penny by making a box plot. Quick comment here, box plots are also referred to as box and whisker plots sometimes. It means the exact same thing. And another comment about these plots, there's 2 different types of them. One type that specifies outliers like you see here, and one type that does not specify outliers. That's a little bit annoying, I'll talk more about that at the end of the video. But for this problem, what we're being asked about is the interquartile range. So what you need to know about the interquartile range is that it's always equal to the difference in the first and third quartiles. In other words, Q3 minus Q1. There's lots of different ways you can figure out the first and third quartile. You can get those numerically out of your calculator, for example. But in this problem, we're supposed to pull them off of this box and whisker plot. So box and whisker plots, they can be oriented vertically like you see here, or horizontally, in which case this plot would look something like this. And whether they're oriented vertically or horizontally, often you see 2 of them side by side. So maybe you can imagine another one right here side by side for the sake of comparison. But none of that happens in this problem. In this problem, you're just given one box plot. It's oriented vertically, and you're asked to figure out the IQR. As I talked about, IQR is the third quartile minus the first quartile. So if we can pull the first and third quartiles off of this box plot, we'd be done. Conveniently, the box part of the box plot always tells us the first and third quartile. The top of the box, if it's oriented vertically, is always the third quartile. And the bottom of the box, if it's oriented vertically, always tells us the first quartile. As you might guess, if it was oriented horizontally, the first quartile would be the left edge of the box, and the third quartile would be the right edge of the box. The line in the middle of the box is always the second quartile, and you're like, whoa, I've never heard the word second quartile used. Right, it's usually referred to as the median, but it might help you remember that it means the exact same thing as the second quartile. And if your box plot does not specify outliers, this one does, but if it does not, then the bottom and the top of the line that extends from the box tell you the min and the max. However, if your box plot does specify outliers like this one does, the top and bottom of this line tell you the largest and smallest observations that themselves are not outliers, because outliers are specified either with a plus or an asterisk or something like that. Anyways, in this problem, it appears that the first quartile is, what, I don't know, like 4 or so, and the third quartile is, I don't know, like 19 maybe. So the interquartile range is roughly 19 minus 4, in other words, 15. If you go look at your answers, you won't see 15, but 16 is pretty close. So for the sake of the approximate interquartile range, the correct answer would be C. A little bit more on these topics while we're here to prepare you for your test, not necessarily just answer this question. If you pull up your graphing calculator, which likely looks something like this, and go into your stat plot, so second and then y equals, when you go in the plots, you'll see 6 different icons for the types of statistical plots that your calculator can make. If you stare at the third and fourth options, they look really similar. The reason they look really similar is because they're both box plots. You're like, whoa, my calculator can make 2 different types of box plots? Yes, again, one with outliers, one without outliers. How can you tell which is which? Well, if you look at the icon really closely, you'll see some dots outside of the lines on this 4th icon, whereas on this 5th icon, you won't see those dots. Those dots are themselves the outliers. So if you want a box plot that shows outliers, you're picking the 4th icon. If you want a box plot that does not show outliers, you're picking the 5th icon. If you pick the 5th icon, then the end of this line is the largest observation, not the largest non-outlier. For what it's worth, I tell my students that we will never use this 5th icon and we will only use this 4th icon, because otherwise it gets pretty confusing. I suspect the test makers will do the same thing. When they refer to a box plot or a box and whisker plot, they'll be referring to this 4th icon that does specify outliers. But I suppose they could say, create a box plot that does not specify outliers, in which case you'd be using this 5th icon. One more comment about the outliers. The criteria that is typically used, which would be used on this test and is also used by your calculator to identify these outliers, is based off 1.5 times the interquartile range. So what I'm saying is, in this case, the interquartile range is 16. If we take the first quartile and we subtract 1.5 times the interquartile range, if the first quartile were at 4, and we subtract 1.5 times, I'll use 16 instead of 15 so that I'm using the answers they chose. 1.5 times 16 is 24, and 4 minus 24 is negative 20. This is the cutoff for something being an outlier. It's referred to as the lower fence. Any observations less than negative 20 will show up as an outlier in your box plot. In this case, it looks like the smallest observation is 0. so we don't have any outliers on the lower end. A similar calculation can figure out your upper fence, except now instead of starting with the first quartile and subtracting 1.5 times the inner quartile range, we're going to start with the third quartile and add 1.5 times the inner quartile range. It looks in the picture like the third quartile is 19, but I'm going to use 20 for the third quartile for my calculations so that things line up with the answers that they have here. 20 plus 1.5 times the inner quartile range is 20 plus 24, which ends up being 44. A comment here, the lower fence and upper fence do not directly show up on your box plot, right? This 44 right here is not the top of this line. A lot of people think it is. The top of this line is not your upper fence. It's the largest observation that you have that is less than or equal to your upper fence. So in this case, it looks like the largest observation less than or equal to 44 was about 40, but then there was also an observation of 50. Lots of different ways this question can be asked, but the key things you want to be comfortable with is the inner quartile range and how you can get that from the first and third quartiles, figuring out the first and third quartiles from a box plot, and then this idea of outliers and where they come from. I think that's plenty on this problem, so I'll call that good here.